Good morning. It's 6 a.m. and your alarm is ringing. You reach your hand over to shut it off. After that, you somehow find the energy to get up from bed and stumble groggily towards the door while tripping over the bedside table in your darkened room. But what's the first thing you need to do? We turn on the lights, of course. However, most of us have no idea how the light switch even works. When we flip on the switch, we completely take for granted that somehow electricity is being routed and connecting a circuit which allows the light bulb to turn on. But the real question is, where is this electricity even coming from?
Electricity can be generated in a variety of ways. Most commonly, it is generated by rotating a set of magnets near copper wires. This rotational movement creates a magnetic field, which in turn directs the electrons through a wire, creating a flow of electricity. There are many different ways to provide this rotational movement. In the United States, a whopping 39% of the electricity generated comes from coal-fired power plants. But what actually goes on in a coal-fired power plant? Before the process of generating electricity begins, coal needs to be mined, refined, and transported to an existing coal-fired power plant. After this, the coal is ignited and used to heat water, which turns into steam. The process begins with coal being systematically funneled into a power plant. New coal must consistently be purchased to keep the factory in running state. Essentially, we are funneling money into the power plant all the time. Once it has reached the furnace, it is burned to produce heat energy. The smoke from burning the coal escapes through a smokestack, releasing carbon dioxide and carbon monoxide, which are both greenhouse gases, into the atmosphere. This heat is used to boil water to produce steam. The high pressure of the steam is then used to rotate a turbine, which produces mechanical energy. The turbine is connected through a gearbox to a generator. A set of magnets is housed inside the generator, and the rotation from the turbine is amplified by the gearbox and used to rotate the magnets within coiled wires. This creates a magnetic field that directs the flow of electrons, producing electricity. The electricity then goes to a transformer, which increases the voltage, after which it is able to travel through wires over long distances to power your home.
Now, how does this process compare to other methods of generating electricity? What if we told you that half of the steps could be cut out? A wind turbine works in a similar way to a coal power plant. Except, instead of burning coal to produce steam to push a turbine, a wind farm uses the naturally occurring energy in the wind to produce the same rotational movement. The wind turbine has many of the same features as a coal power plant. For example, it also houses a turbine, generator, and gearbox. The turbine generally consists of 3 blades and a wind vane that causes the structure to face the wind. This allows the turbine to capture the highest possible amount of mechanical energy from the wind. The mechanical components of a wind turbine are the same as those of a coal-fired power plant. However, the expensive and energy-intensive process of using coal to produce steam is replaced by readily available wind.
What other options do we have? There are many alternative methods of producing electricity aside from coal-fired power plants. Some of these include wind, solar, wave, and geothermal. Geothermal plants work by harnessing latent heat energy in the earth. In order to capture this heat, cold water is piped deep into the ground where hot rock is present. The cold water is heated by the rock and circulates back to the surface. Once it reaches the surface, it goes through a heat exchange. The hot water is used to heat up a separate pipe of cold water, which turns to steam. The steam is then used to power a steam turbine, just like in a coal-fired power plant. Solar panels offer us another method of generating electricity. Solar panels can produce electricity in a different way than we have previously described. They are able to take energy from the sun and output an electrical current. The cost of making a solar panel can be paid back within 2 years of its installation from the electricity it can generate. The average lifespan of a solar panel is 30 years. So, how efficient is that?
Efficiency is the ratio of output over input times 100. In this case, our input would be 2 years and our net output would be 28 years. If you divide 28 by 2, you get 14, and after multiplying by 100, you're left with an astounding 1400% efficiency. So what can we do about this? Some options are to use less electricity, support renewable energy sources, use energy-efficient fixtures, and insulate your home. And our final question to you is, where does your electricity come from?